So again, we're still on the reaction of alcohol with SlCl2, and for this reaction, it involves pyridine, no? And the usual alcohol here is a 1 degree or 2 degree alcohol. And once your alcohol is attached to your SlCl2, okay, the proton, the pyridine, can easily deprotonate your alcohol here. Once it becomes deprotonated, no, you have this structure. There's a name for this. Your alcohol tosyl chloride is called as tosyl chloride. And now once you have this one, the structure RO, S double bond OCl, what will happen is that your nitrogen, your electrons in your nitrogen gikan sa imong pyridine can attack your sulfur. And pag attack niya, the electrons, the electrons go to there, balik to the, then will leave siya. And you have your ROS double bond, the pyridine ring, and it's protonated. No? And then once you have this structure, your oxygen now becomes a good living group, and chlorine can easily attack your alkyl halide, your carbon here, the positive carbon. Pag attack niya, it follows the Sn2 mechanism. Actually, you don't proceed with an Sn1 mechanism. Pag attack sa imong nucleophile, then this living group leave your alkyl halide, you have your RCl, and you have this one. And again with that, what happens is that it follows, it can be relieved, no, forming a double bond here. It can do electron delocalization with this, but it's also possible this one can be recovered. It becomes like a catalyst, the pyridine actually can recover, and you'll have your OS double bond. And instead of this one doing the electron delocalization, it's the pyridine that will leave. No, it will relieve the positive. It will relieve the positive charge of nitrogen, for nitrogen being an electronegative atom. Nitrogen being an electronegative atom, dili siya ka-bear to be carrying the positive charge, just like an oxygen. So it needs to be relieved by drawing the electrons, gikan aning a bond, and you will recover the lone pair here. So nitrogen still recovers its octet 2, 4, 6, 8 with electrons here and neutral. Okay, and what is being produced actually is your SO2, with sulfur dioxide. And this reaction with SlCl2 and in the presence of pyridine, which becomes our catalyst, actually produce your RCl. So this is not the final product here for it. For this one, you always reduce your gas SO2 and your pyridine. So there are just for alcohol, one of the reactions of alcohol, the usual reactions of alcohols, no? When it reacts, it has to leave. So if it undergoes substitution reactions, the other reaction of alcohols that you have learned with the previous chapters is that it can do dehydration reaction to produce an alkane, remember? But if it doesn't form dehydration reaction, it can act as a living group for a substitution reaction. No? So your alcohol, your alcohol always is not a good living group. See, ROH, no, if it leaves the alkyl, as an OH, dili na siya mahitabo. We need to derivatize that one. We need to protonate that, becomes an OH2. Kailangan at kay OH2, positive charged oxygen in that OH2, no, to leave the substrate or the alcohol, or we need to derivatize our alcohol. So instead of pag-derivatize, katong kaganina, no, we derivatize that one with this one, para dali ra siya mobiya. It becomes a good living group because of this. No, it can be stabilized with this one. There is a driving force for this, becomes a good living group. So this one, your chlorine can now easily attack your carbon. Kung OH lang siya, no, like this one, kaganina. Kung OH lang siya, and then si Cl dione attacking this, dili na siya mahitabo. We need to derivatize this. The first one is katong gingon na to kaganina. Again, protonation. Ano naman to? At saka tong protonation, the other one is, we derivatize that one with SOCl. We need to react this with SOCl in the presence of pyridine. So other than that, na-apply another derivatives of other ways of derivatizing our OH. So can use the group OTS, tosylate, like this one, or we can use mesylate like this one. Usually na siya sulfur, adoban OOO. Okay, you can have also this as adoban O. So pwede na to si oxygen, imo na to siya nga bounded siya ani para mahimo siyang good living group. This one is OTS or tosylate. You have the S. You can see the similarity of the structure. You have the S, adoban OO here, and a benzene ring and methyl, like toluene group, and this one a methyl. So this one is tosylate, this one is mesylate. So the requisite space, we need to have a direct replacement of our OH group with the nucleophile via the Sn2 reaction is not possible since OH is very poor living group. Again, if we don't use acids with alcohols, especially for dealing with 1 degree, 2 degree alcohol, we don't proceed with an Sn1 reaction because we don't produce a carbocation in the reaction step. Instead, we follow the Sn2 mechanism. Again, in the Sn2 mechanism, there is a simultaneous backside attack and leaving of the living group from the substrate. And of course, you know the stereochemistry, there is with the Sn2 mechanism, there is an inversion of configuration. You already memorized that one, Sn1 and Sn2. Okay, so again, again with this, for OH to be a good living group, we need to, this one, as I've already mentioned, if we have a nucleophile and just directly react with alcohol, hindi na siya reaction mahitabo. So para to proceed with the reaction, we need to derivatize this one because even if the nucleophile can attack this, this carbon here is partially positive, being bonded to your oxygen. Dali siya maka-attack sa nucleophile to attack here, but even if mo attack siya, matam siya attack, OH doesn't leave. There is no driving force for OH to leave unless himoni mo siyang OH2 na siya charge nga positive. So there is a reason for it. There is a driving force for OH to leave, kaya kailangan niya i-disperse ang positive charge. Pero inani lang, malagin na siya reaction. So we need to convert OH minus or OH to be a better living group first before the reaction proceeds. So we have already mentioned earlier, we have already seen the reaction of an OH to be a living group. It's either may protonate natin siya to become OH2 plus or i-react siya with PBr3 or SOCl2 with pyridine, nahimo siyang good living group once forms a bond with SOCl, SO, and then the S bobanon under the ring. Then another way is we can derivatize that one with mesylates and tosylates. So how do we derivatize this one? The same with how we use with SOCl2 is the same way that we derivatize that one with Okay, so we can derivatize the same way again kaganina. We use SOCl2 as double bond ClCl, di ba kaganina with SOCl2. Parihara po siya, similar siya. So we can use methane sulfonyl chloride with this one. And what happens? So we use pyridine, Sa pyridine, katong kaganina, it can, you have your CH3SO, you have your pyridine. What happens is that you will have your pyridine, no, i-abstract niya si proton here. Okay. And what happens? Your oxygen can attack your sulfur diri. Okay. Pag attack niya ang sulfur diri, what will happen is katong kaganina, double one of the bond will be converted to oxygen. Okay. And then it will have a negative charge. Pagbalik niya, no, kaya ka-form naman siya og bond kani the O here, the sulfur. It's the O that will attack here. I need to use pen. Use ako pen. Oh, anyway, I don't know what to draw here, so is there a I'll just use paint. I'm currently using my old laptop. It's very slow. So anyway, so remember, yeah, here. So what happens? Your pyridine. Okay, start with pyridine. Pyridine is this. Okay, you have your pyridine. Your pyridine actually will abstract. This one. Okay, here you have your oxygen, it's just partially negative, partially negative, partially negative. And this is your sulfur, which is partially positive. And your oxygen, NH lone pair, remember? Remember, NH lone pair. So it will attack your sulfur, right? And when it attacks your sulfur, what happens is that kaning electrons here will go pa yun dali, right? And your pyridine, it's your pyridine structure. The pyridine is okay, a lone pair. This is the one that will obstruct. Okay, let's just form first this one. Let's just form first this. Once you form this one, you will have your copy. 1, 2, 3, 4. So you have 1, 2, 3. You have your O. Okay, and you'll form with sulfur, right? Double bond O. And you have your O. You have your O, and then you have your CH3. Okay. First you have your lone pair, and you have your lone pair, the potential lone pair. Okay, and of course you have your hydrogen here, and then you have your positive. positive oxygen. And here, there is 2 lone pairs. Ikan sa duha, no? Ikan sa duha ka lone pair. Ano siya? Ay, ma-convert man siya to here. Okay. So you have a unom and with a negative charge, of course. Right, so once you have that one, your pyridine then will obstruct your proton. Si pyridine will obstruct your proton. Mahimo siyang pag-obstruct na niya, balik na siya dito. Okay, so once you mahitabo, then you will have your ma-deprotonate sa oxygen. But this one ay napatay Cl, CSO, SH3. So 1, 2, napatay Cl with me. So 2, 4, 6, 8, 10, 12. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5 ko lang napay Cl diri. Napay Cl diri. So proton, the pyridine, the purpose is to deprotonate protonated ng alcohol. But what happens is that oxygen would having a negative charge, you'd need to disperse that one. So you will have your balik ka na niya dito, this one will leave. So what happens? You will have this one, SO. So 2 steps na siya, actually 2 steps na siya. Pagbalik ka na niya dito, si oxygen, mahimo na siyang O, S, double O, gani. And you have your CH3 and you have mawala si Cl. So you have your Cl here. And then si pyridine, iyang i-deprotonate si alcohol, and you can have kani, si pyridine, that you'll have this one. Okay. And once you have this one, you have your Cl here can now, use another color na lang. Your Cl, given the react, can now attack. Anyway, you have here, once you have your Cl, you have another reaction here. Or another reaction. You have here, okay, Charlotte, you have your Cl, so minus, then it can attack now your kaninga carbon, pag-attack na niya, it now becomes a good living group. Okay, and you will have your it's black. You now have your 2, 3 Cl. Okay, so 2, 3, 4, 1, 2, 3, 4. And now you have your Cl. Once it leaves, you will have your S plus, of course, your O. Okay, naman na siya ito hakalong pair. Okay, you have your S, double bond O, CH3. Of course, you have this negative charge, right? So this one, OMS, your mesylate, SO. Okay, so once katong given the reaction, and once you have this, that can easily leave and can easily substitute, or this one can easily, once you have this one, can easily be attacked with your chloride. Okay, and the same with mesylate. You can also have tosylate, no, with alcohol. We need to derivatize your OH with tosylate. So some ng tosylate. Your tosylate is very heavy sa mesylate. Instead of methyl here, get your pyridine Your pyridine, you get your benzene ring with metal here and toluene group here. So what happens? The same nagyapon, no? This one will attack sulfur. Okay, pag attack ng sulfur, kanya siya mabalik din. Pagbalik, pagutang niya din, mabalik siya dito, matanggal niya siya. So you have your S, double bond O, and then kanina group. Okay? Kasi OH, pag form niya og bond kang sulfur, protonated man na siya. Okay, get your pyridine. As you get your pyridine, i-deprotonate na siya. I-deprotonate, you'll have this one. Okay, so now you have steps on it. And once you have this one, it's the same as OTS. This one is distillate. And can easily leave your ring. Once you have that, you have your para, toluene, sulfonyl chloride. Para, because this one is para to this. Para, toluene, sulfonyl, OTS. So Sn2 displacement of mesylate or tosylate with a nucleophile is possible. And again, I've mentioned once you have your tosylate, OTS or O-tosylate, you can easily attack. Once you attack, and OTS can leave, you can have your nucleophile here. So it's either OTS or OMS. No? Dali rama, replace the oxygen. So you have your tosylate chloride, pyridine, like here. What happened is that in the presence of pyridine and tosylate chloride, the hydrogen can be replaced with tosylate. Okay, so you have your tosylate, and it can be attacked with a nucleophile. In this case, your nucleophile is sodium Cn, your cyanide, in the presence of our solvent DMS, or dimethyl sulfoxide. So you notice here that this is our nucleophile, Cn minus. I remember last time, was it 130, no? It's hard for you, or even sa exam naturalist, it's hard for you to identify the nucleophile. So for example, you are given with an ion, sodium plus and Cn minus. Katong na ay electrons, katong na ay usually na ay electrons, na ay negative, pag ginatong nucleophile. So for example, sodium cyanide. So dili ni siya tanan nucleophile, kana siya nga part, no? Because the positive one is an electrophile, electron deficient. Okay, so this one will attack this, and O can easily leave because it is being derivatized with tosylate, kaning TS. So whenever you see in the textbooks nga na TS, know that this is tosylate. Or some other books na ginabutang niya ang TS din. So do not forget what is TS. It's simply katong O, S, double bond O, and then you will have S double bond O, and they have your benzene ring with a metal, so tosylate. For others, if it's mesylate, it's O, S double bond O, then you have your methyl. Okay, so again, pag si oxygen derivatize siya with another group, tosylate or mesylate, no, dali ra siya undergo substitution reaction. And since we undergo substitution reactions and we don't follow the formation of a carbocation via the SN1. So this kind of reaction doesn't follow SN1. So unsa pa may isa kaklase nga substitution, it is the Sn2 mechanism. If you remember, in the Sn2 mechanism, it's always a backside attack. So this one is protruded towards you, directed towards you, your nucleophile will attack from the back, no, sa likod. So once it's attacked, there will always be inversion of configuration, and your product would have an inversion of configuration as this, right? Okay, it will not attack man diri nga parts of front, will attack from the back. There will be, remember your Sn2, there is a simultaneous bond formation and bond breaking process, and there is inversion of configuration. So for instance, wala na ko nang check na if it's RS. If this is R, the product will become S. So if this is oriented towards you, the O is oriented towards you, the other one will be oriented away from you, like this one. This is what you call as inversion of configuration with an Sn2 mechanism. So you are able to replace the OH here with Cn via the Sn2 mechanism. When your reagent is tosyl chloride and pyridine, you have here, this one is wala pa siya inversion of configuration. Take note, ha, because we don't replace oxygen in formal bond with hydrogen. This is not our final nucleophile. This is still a derivatizing agent, tosylate rather. Okay, and this is our nucleophile now, attacking your carbon here. Okay, and it attacks from the backside. Attack now via Sn2 mechanism again. So what happens is that now you will have, kani siya mo leave siya as OTS na siya negative charge. Yung negative charge man siya, then si sodium will be in tandem with the negatively charged oxygens. It becomes ionic. Okay, I hope napakating malunggan. This one again, there is retention and configuration. But when you do nucleophilic substitution via Sn2, there is inversion of configuration. Again, kani wala pa ta nag-substitution ani, nag-derivatize sa takang oxygen with tosylate or methylate. Okay, so another reaction. Do you have questions? Asang uban? Do you have questions? Any questions? Okay, so let's proceed. Let's have another reaction. Methyl chloride here. Methylate rather. Methylate chloride in the presence of pyridine. Nganong gamit ang pyridine? The pyridine is used as a base, a Lewis base. Pag ma-protonate manggod si alcohol, okay, o ma-protonate sa alcohol. Pag si alcohol manggod would have more than 3 bonds, so himo siyang positive, and to eliminate the positive charge, okay, eliminate the positive charge. Ano naman ito, right? Example. Kanina lang. Kani, pag naay positive charge si oxygen, no? Kani. Pag positive charge si oxygen, kailangan, of course, ano siya, lone pair, kailangan matanggal ang positive charge, no? And the use of, pyridine, ring ni siya. Or parihara na siya. Okay. Kailangan matanggal ng isa ka bond. And usually, si proton man dali tanggalon. So, si pyridine, which is a base, this one acts as a base, a Lewis base, it will attack this one, the proton here, and the bond with the oxygen balik dito. So, man-neutral na siya dili. Okay? That is the purpose of pyridine. Kanin is pyridine. Let's have another example. Methylate chloride. So here you have a primary or a secondary alcohol. Anyone? Someday ang intindi. Ronel, is this alcohol a primary or a secondary alcohol?
Pardon, ma'am?
Is this alcohol a primary or a secondary alcohol?
Secondary alcohol, ma'am.
Okay, it's a secondary alcohol. So here, since it's a secondary alcohol, you don't have an acid, you don't have an acid, and you don't have reagent like an HX. Now proceed via the Sn2 mechanism. So we're using methylate chloride here in the presence of a fluidine. So now we have a partner here. Can't think. So this one need to derivatize our OH. Now it needs to undergo substitution reaction. So derivatize this one. Kata akong show earlier, na you can derivatize this to form OMS. Ang shortcut na ninyo. If you need to know the details, you can go back sa katong hindi pa kita kanina. Anyway, so here what happened is the hydrogen is being derived, the OH is being derivatized with methylate. Now, para mahimo siyang, again, the purpose is for the OH to be a good living group. Pag dili na siya either ma-protonate or ma-derivatize wala gi substitution reaction na mahitabo. So we're trying to derivatize again the electrolyte mesylate here. Okay, with mesylate chloride, the presence of pyridine, we need the pyridine to deprotonate or protonated O once it becomes derivatized. Monopurpose pyridine. So again, once you have the O mesylate here, then you can have your noctufol, there's sodium thiomethyl, and have a negative sulfur here, and in the presence of a solvent, you can substitute this one. So what happens if this is up, no? There is an inversion of configuration, there is a backside attack that will attack here. So there is a backside attack, so it will attack this side here. So if it's up, this becomes down. And you'll have your sulfur attacking your carbon here. Sulfur is our noctufol containing electrons. You'll attack your carbon here, being positive. Okay. Again, so this one is still we are derivatizing. There is retention and configuration, but once you do substitution reaction, there is inversion of configuration in this carbon. Okay, so I think we're done with the reaction of ethers, alcohols. And now we can proceed with the reaction of ethers now. Many slides. Okay, so stop share. So I would like to continue my discussion, by the way, but before I continue, like now, like after, I'm gonna have 30 minutes break so I can have a makeup class for what I have missed in the previous meeting. And if you are available, you can watch on the recording the discussion with ethers. Okay, so that ends our discussions for the reactions of alcohols. If you have questions, you can ask me now or later. Do you have questions? And we will proceed the reactions of ethers. I will proceed the reaction of ethers in 30 minutes. So I'll just take a rest of my voice. And after that, I'm gonna have maybe 1 hour discussion. Okay, so if you're available in 30 minutes, I will be talking about reactions of ethers. And of course, I will upload our discussion so that others who are not here will be able to watch the video. Okay, so see you in 30 minutes if you're available. You have no questions, and of course, we'll upload problem sets for you to work on, apply on the reactions for alcohols and ethers later. And I will just use the same link. This is the only way for me to record now because don't have a recording device. Don't use the screen recording device. It's very heavy in my laptop. We'll see you in the 30 minutes. We are still around. One final instruction. So I will make an announcement for tomorrow's activity DI, an activity, and tomorrow there will be an observation actually for those who will be going to the laboratory. Okay,